Hey guys, I'm going to help you with the back side of the assignment today. The excuse me, the first page you should be able to get using your notes. Okay. So for part 1, it wants you to draw an arrow in the compass circles to designate the direction of the magnetic field at those locations near the permanent magnets. Okay, this first one it didn't print well, so hopefully you're watching this video so you can know that there's supposed to be 4 circles or 4 compasses around this magnet. And this is where they would go. Okay, so think back to the lab yesterday. All right, we know that the compass always points north. Okay, or yeah, points to the north on Earth, but the north that it's pointing to is actually pointing to Earth's south magnetic pole because that's the one that's up north. Okay, so that means it always points towards the south. Okay, or the South Pole. All right. Um, so this compass will be facing the south. This one is north. We can't make it face the south this way, okay? Because that is, if you have two north poles facing each other, what's going to happen? They're going to repel each other. So this one should actually be facing away from the north because again, it's repelled. It's wanting to go the opposite direction. These two compasses will be pointing towards the South Pole. Okay, so when you're doing these, you want to make sure the arrows goes away from the north and towards the south. This can actually help you with some answers on the first side of the page if you didn't know them too. Okay, so use this knowledge to help fill in these compasses for problem 2. Again, you want to make sure that your arrows are facing away from the north and in the direction of the south. Okay. Let's see. For part 2, draw an arrow or dot or an X in the compass circles to designate the direction of the magnetic field at those locations near these moving charges and current carrying wires. Use the right-hand rule number 1. Let circles with a dot and then represent direction out of the page, and circles with an X represent the direction in the page. Okay, so again, this is wanting us to use the first right-hand rule. So if you have your notes from yesterday, okay, the first right-hand rule, we're going to be using our right hand. You're going to point your thumb in the direction of the current, and then you're going to wrap your fingers around the wire. The magnetic field wraps around the wire in the direction of your finger curl. So what you're going to do here, okay, is you're going to point your right hand, okay, right hand, you're going to point the thumb in the direction that the arrow is pointing, and then you're going to curl your hands around it. So let me scoot this over. Okay, so again, it's going in the direction of my hand. So it's going into the page on the bottom. It's coming out of the page on the top because it's going like that. Okay, so if it's going out of the page, then we're going to use a dot. And if it's going into the page, we're going to use an X. Okay, so again, that's what you're doing. You're using your right thumb in this page, okay? And you're pointing it the direction that it asks, and you're following the rules, okay? Now, or I said in the direction of the arrow, but you want it to be in the direction of the current. Okay, so my hint for these is if this is the direction that the electrons flow, remember from the electricity unit that electrons flow opposite, okay, of current. Okay, so the electrons flow the opposite of the current. Okay, so since the electrons are flowing this direction, if they're flowing opposite, that means the current is actually flowing in this direction. So make sure you're aware of that as you're doing the rule. Okay, protons flow with the current. Okay, so this one stands as it is. All right, so you can fill in the compasses here. And this one, again, it didn't copy. I don't know why. All right, but we're going to pretend that this is a proton. Okay. And lastly, for part 3, says state the direction of the magnetic force on these moving charges or current carrying wires when near these external magnetic fields. Circle with a dot and then represents the direction out of the page. Circles with an X represents the direction in the page. B is the letter that designates the magnetic field. Okay, so when we have two fields that we're having to look at, this is going to be rule number 3, okay? So right hand number 3. So when we look at our notes from yesterday, okay, you are using your right hand. You're going to point the middle finger or point the fingers in the direction of the magnetic field. Point your thumb in the direction of the wire's conventional current, and the palm of your hand will face the direction of the forces acting on the wire. Okay, so here we're going to point the fingers. This is kind of awkward, sorry. Okay, so the fingers go in the direction of the magnetic field, and B designates the magnetic field. Our thumb needs to go in the direction of the current, so our current is going to the right. Okay, so which way is my palm facing? Okay, here's my palm. All right, my palm is facing into the page. Okay, so that means that this is going to be an X. Okay, the force is going into the page. All right, so again, remember this one can be weird. Okay, fingers go in the direction of the magnetic force. Thumb goes in the direction of the current. Okay, and then you're looking at the direction that your palm faces. Okay, so you could be using arrows if it's going to the left or the right. You could be using remember the compass with a dot in the middle? Means that it's going out of the page and there's no X's. Okay. Don't let this trick you up right here. Remember what we talked about with electrons, okay? Means that the current's going opposite. All right, so use that. Do your best to answer these questions. Then make sure that you go to the next page when you're done with this and enter the questions that it asks into the knowledge check quiz part. All right, you guys have an awesome day, and I'll see you later.